What did somebody get for the Dom? One of these. Good. Malik. Do you think 4 and 5 are congruent to angle 3? All right. Anybody else? Donovan. Why angle 6? Okay. Anybody else? Well, the correct answer was angle 6. I'll be showing you a way to know that later. Now, maybe it would have been a little clearer had I drawn them like this. See how much narrower those are than the ones? And if I had oh, it's frozen. If I had the angle 3 here, then it would have been a little clearer that this is the one that's congruent or equal to it, because this one is so much bigger than this one. I'm going to, a little later today, be teaching you about these angle relationships and how you can know things about them. But the big thing to remember about when you have an intersection and creating 4 angles, a lot of times when it's drawn like this, it's going to be pretty obvious which 2 are congruent to each other. The big ones will be congruent, and the small ones will be congruent. And I'll be showing you other ways to know which ones are, but that's a key thing you can always just fall back on. Questions? All right, we are in 1.5, angle pair relationships. 1.5. Oh, don't do this to me. If you all would. First thing, piece of notes, complementary and supplementary angles. Complementary and supplementary angles. Again, you're not required to write this stuff down, but it may prove useful. Since tomorrow's a quiz, I guess I'll go ahead and tell you this. I was going to wait for your first test. When I was in school, I was not a note taker. I was like, what's the point? So to discourage that, because note taking really does help. I wish I had known that at the time. So to get you all to better appreciate notes, I'm going to allow you to use anything that you have handwritten on your quizzes and tests. Homeworks, notes, whatever. Anything that you have handwritten, you may use on the quizzes and tests. I can't guarantee you when you'll get those back. If you do, then you can use them, but I'm not going to guarantee that. But especially your notes. You'll always have those. So anything you handwrite, you can't copy anybody else's. You can't copy anything out of the book. But if it is handwritten by you, you can use it on quizzes and tests. Now, I will throw this warning out there. A lot of people think that, oh, I can't possibly fail. I've got everything from the whole year. But then they're so disorganized, they waste so much time looking for everything. So I would recommend that the night before said quiz or test, you organize and what it is you know you'll need so that you're not looking through so much stuff. But there's that. So yay notes. Complementary means they add to 90 degrees. Means 2 angles. Actually, I guess it could be more, but most likely it's 2. Yeah, 2 angles. Add to 90 degrees. So what would be complementary with 60? Oh, thank you. Trip. 30. Very good. Supplementary means they add to 180 degrees. Supplementary means they add to 180. So Now, remember how the other day I said bisect and was like a key word that'll tell you what to do with the problem? Well, so are supplementary and complementary. You're going to have problems where the only hint you're going to have on how to solve it is such and such are complementary. Well, you need to know then, complementary means that two things do what with each other? Add to 90. Now, just like yesterday. Remember how yesterday I said if two things are equal, then you set them equal. Same principle. If you hear that something's complementary, that means they add to 90. So if it gives you two things, even if they have 2x plus 7 and 3x minus 6, guess what you're going to do with them? If complementary things you add to 90, then what do you think you do with two complementary things that you'll have in your homework? Add them and set them equal to 90. Exactly. Same thing for supplementary. If it tells you things are supplementary, it doesn't matter what they are, it means you add them to 180. Adjacent angles. Adjacent angles are basically two angles that share a common side, but that don't overlap with one another. Adjacent's kind of a fun little math word that you see now and again in all math classes. It basically means they're neighbors. They share a common side. Similarly, you and your neighbors, wherever you live, share a yard line. Your yards don't overlap, but you share that boundary. Yes, sir. That's a good question. All four of those would have been adjacent. Maybe not the ones that are directly opposite of each other, but each one of them and their immediate neighbor would have been adjacent angles because they shared a common side. I actually have pictures of it, but I was going to let you all get this written down, and then I'll show you pictures of it. But yeah, you're right. There were each of those angles had two adjacent angles with it in that picture. Is everybody who wants to write this got this written? Okay. No problem. All right. So, here are what complementary angles and supplementary angles look like. And here are what adjacent angles would look like. See how they're connected? And these would be non-adjacent angles. Similarly, these would be adjacent because they share a common side and vertex. And these would be non-adjacent. Adjacent, non-adjacent, complementary, they will add to 90. Supplementary, they will add to 180, a straight angle. Questions on that? Okay. In the figure, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. Somebody want to raise your hand and tell me what those would be. Let's start with complementary. What two angles in that picture are complementary? Add to 90. Blake? Excuse me? Yeah, well, how would you label that angle? ABC technically means this angle, because B would be the vertex. So you would have to call it BAC or CAB. So we'll call that angle BAC. And what angle are complementary? RST. Very good. They add to 90. 32 plus 58 is 90. Those two are complementary. What two angles are supplementary? Someone else. Yes, ma'am. Perfect. DAC and RST are supplementary. They add to 180. Very good. And last but not least, what's a pair of adjacent angles in this picture? Jensen, where do I have adjacent angles? Would you like to phone a friend? I'll call on you very soon in the future. Yes, ma'am. BAC and what? Very good. CAD. What makes them adjacent? Right. They share a common side. They're neighbors to one another. When it comes to adjacent, you don't care what their measures are. It could be 1 and a billion would be impossible. But it'd be like 1 and anything else, or it doesn't matter what their measures are. All that matters is that they share a common side. Very good. Questions? Here's another question. Given that 1 is a complement of 2 and 1 is 55, what is angle 2? Salvador. First part. You know what this would be? Okay. Somebody else want to take a stab? Yes, sir. How did you get 35? Very good. Complement. 90 is what 55 plus this, I'll call it x, would equal. So x equals, or angle 2 equals 35 degrees. No, they both mean add. Complement means 90 degrees. Supplement means 180 degrees. So now that you know that, you want to tackle the second one? What plus 80 equals 180? I'll set it up for you. Supplement, which means you're going to take the two angles you have. We're going to call this x again. And supplement means they add to 180. So subtract, and what do you get? Hey, there's nothing wrong with that. Checking your work. There you go. 100 degrees. Supplement means 180 degrees. Complement means 90 degrees. Thank you. Questions? Key pieces of vocab. All right, over halfway done. Same thing, except this one has a picture. When viewed from the side, the frame of a ball return net forms a pair of supplementary angles. Freeze frame. Supplementary. What does that mean? Malik, what does that mean? They measure up, meaning we should do what with them? Boom! We add them, and they should equal 180 degrees. So that's what we're going to do. We are going to add them. Let me just uncover the whole thing. We're going to add them, this angle plus this angle, and set them equal to 180 because of the word supplementary. Then, you just combine like terms. 4x plus 1x is 5x. 8 plus 2 is 10. Subtract the 10. Divide by 5, and you get x is 34. Are we done? No. What do we have to do now? Man, you guys are getting downright trained. Plug it in. Take that 34 and plug it in. We plug 34 into 4x plus 8. 144. Excellent. Plug it into x plus 2. When you are done, you can check. Are they, in fact, supplementary? So we did it correctly. Yay. Questions? Well, the only thing that probably made this one look hard was A, it was the first one that had equations in it, and B, it was a picture. A little harder to see. But supplement was the key word. Questions? Where did we get it from? We took our 34 and we plugged it back into the two originals, and that's what 4x plus 80. That was this angle. And you're going to find that almost all of geometry is, mathematically, as far as what we do, setting things equal and adding them up, that's not going to change all year. Really. I mean, we'll have little things here and there. But like seriously, in every chapter all year, we're going to be doing things like setting things equal and adding things to 180. A lot. Mathematically, geometry is one of the easier classes. Where it gets complicated is, see, like, what have I thrown on you today? I've thrown on you today that you're going to need to recognize, oh, those two angles are supplementary. And I'm going to be giving you more and more and more stuff like that, to where at some point in time, you're going to have pictures of all kinds of crossing lines, and you're going to have to know, this angle is equal to this one, or this one adds to 90 with this one. That's where geometry can get complicated. But mathematically, it's really not. Okay. How would I set this one up? You don't have to tell me what the answer is or anything. How would I set it up? And I'm going to pick someone at random to tell me what my key word would be. At random, I say. At random. Starla. What is the key word in this equation? Or in this, not equation. What's the key word in this problem? Complementary. And what does that mean we should do? Check your notes if you need to. Complementary. Would you like to phone a Donovan? This side of the room. Oh, actually, that's not true. I'm not meaning the group. Twice now. All right, and I think both times Donovan's been our savior. Donovan, what do we do? They should add to 90. Complementary means that two things add to 90 degrees. That's what you'll always do when things are complementary. Now we just plug it in. What's that? All right, then. You tell me what to do. All right. Okay, go on. -2 plus 1. -1. You got it. And what would that give me? Seven. Now what did it say? Find the measure of the angle. So what do? Plug them in. So for this one, that'd be 4. Let me change colors so that people know this is a different part of the problem. 4 times 7 minus 2 equals the 26. I plugged the 7 into the x here. 4 times 7 minus 2. So it's 28 minus 2. All right. Now, here's the thing. Now I'm about to tell you something that really doesn't have to be said. You know how to find the other angle. Just plug 7 in. What's another way we could find the other angle without having to plug it in for the x? Exactly. Wait, what did you say? Yeah, exactly. We know they're complementary, so why don't we just subtract 90 minus 26? You could do either one. You could plug the 7 in for the x, or you could just take 90 minus 26, and you get your other angle to be 64. Go ahead. Okay. Funny. Questions? I can. Geometry is all about finding the key words and directions. Geometry and the science section of the ACT I found are all about finding the key word and the directions. I only mention that because I'm teaching ACT prep and science was never my strong suit. I'm learning. All right, last piece of vocab of the day. Vertical angles and a linear pair. Remember I said we were going to come back to that same picture from the DOM? Well, that picture was this picture from the DOM. And here was what we were actually looking at. So what you want to write down are those top things, or if you want to just kind of draw this picture, we'll talk about it from that picture. Vertical angles and linear pair. We're going to be using those two pieces of vocab all year. And I bet, even without looking at the definitions at the top, you could probably figure out this is a linear pair. It's basically adjacent angles that form a straight angle. What do you think those two would add up to by looking at it? Yeah, 180. They form a straight line. All linear pair angles are supplementary, which means they add to 180. That's if and only if they form a perfectly straight line. If there's any bend to it at all, which we'll look at an example, then they're not a linear pair. Vertical angles is what you did in the DOM. Those are angles that are directly opposite of one another on an intersection. So 3 and 6 would be vertical, and 4 and 5 would be vertical. And Trip, I believe that's what you told me earlier in the DOM, isn't it? You went ahead and told me 4 and 5 as well. Maybe it wasn't. No, maybe it was somebody else. But vertical angles are... Oh, it doesn't say. Well, they're congruent. I really thought it said it, but I guess not. All vertical angles are congruent with one another. So if this was 150, that would be 150. Now, the reason these two pieces of vocab are interesting and necessary is because as our little intersections get more and more complicated, we're going to have more and more of these where just things cross. You know one angle, you know all of them. Example, if this piece is 40, what other piece is 40? 6. And if this piece is 40, what is angle 4? Yes, sir. 140. How did you get that? Yes, you stuck with the vocab. They're a linear pair. They form a straight line. Therefore, they add to 180. So if this is 140, what is this? 140. 140. Let's look at an actual example. Does anybody need me to leave this on the board for a moment? Okay. On the right-hand side? Yes. In fact, I kind of wish they just used the same picture because you're not going to see this nearly as often as you see this. I mean, I know that is nothing more than this without this piece, except this is how you're going to see it most of the time, so you're just going to need to identify. And there's 4 sets of linear pairs. Those are a linear pair. Those are a linear pair. These are a linear pair. And these are a linear pair. You will very rarely just be given a picture as simple as that. Most often it'll look like this. But yeah, they are the same thing. Alrighty. So, here we go. Identify all of the linear pairs and all of the vertical angles in the picture. Now this is tricky because there's that extra arrow kind of throwing off some stuff. Thank you, sir. You want to take a stab at it? What are you giving me? A linear pair or vertical angle? Well, thank you for speaking up. Here's the thing. If I cover up everything but 2 and 3, do those form a straight line? No. Well, 1 and 3 would just be these two. There is only one pair of linear pair in this picture. 1 and 4. Because if you cover up everything but 1 and 4, it does form a straight line. That is the only linear pair in this particular picture. If this weren't here, it would be a very simple intersection. But that's stupid one here, throwing everything off. 1 and 4 is the only linear pair. And there's one pair of vertical angles too. Trip, I'll let you handle it just 1 second. Linear pair, angles 1 and angle 4. Vertical angles. You know there is one more. I didn't see it. And what is it? 4 and 5 are also a linear pair. Good catch. I didn't even see that. 4 and 5 also form a straight line. Let me make sure I told you correctly. But there is only one pair of vertical angles. Let me flip the last one. Let me pick on someone who hadn't spoken yet. Ooh, Donovan's calling you out. Do you think you know where the vertical angles are? Brandon, you want to help him out? No? Rebecca, you want to help him out? Oh, vertical angles, people. Cameron, you want to help him out? Picked on all you quiet people. Vertical angles. Cameron, I have a feeling Cameron's about to give it to me. In the picture. No? Elijah, you want to help him out? I've already phoned like 5 friends. Elon, do you want to help me out? Where are my vertical angles? 1 and 5! That's correct. 1 and 5. You will know that they are vertical if you cover up everything but angle 1 and angle 5, are they on the opposite sides of one intersection? Yes. Boom. The reason these couldn't be is because this one's kind of been cut in half. 4 is bigger than 2, and it's bigger than 3. That's why 4 doesn't have a vertical pair angle in this picture. Only 1 and 5. So it only took us 7 people, but Elon brought us home. Questions about how we got those answers? They may end up being congruent, but they're not vertical because they're not directly opposite one another. They may end up being congruent, but we can't assume they are. Questions? I believe we've got only one slide left. Ooh, yeah. These two angles, oh, you know what? Going back to the well, Jensen, I told you to come back to you. What is the key expression from those directions? Now, what is the key piece of vocabulary from those directions? No. What is the only thing in these directions that we have talked about verbatim in the notes today? I may or may not be imaginarily underlining it right now. Just say these 2 words. I believe in you. Yeah. Linear pair. And linear pair do what with each other? Anybody can answer this particular question. Close. They do, but as far as helping me mathematically, which means they add up to what? You said 90 earlier, which was incorrect, but they add up to 180. So, if they add to 180, what do I do with them? Okay, seriously. Whenever I do this whole hand thing, it means you're going to say the same thing again. If they add to 180, what am I going to do with them? Add them to 180. So 5x, hey, no need for that, plus x equals 180. Very good. If in your notes it says something is congruent, then you're setting them equal. If it says they're complementary, then you're adding them to 90. If it says that they add to 180, then you add them to 180. So 5x plus 1x is 6x, divide by 6. Now it says find the measure of, divide by 6. It says find the measure of the angles. What's this angle going to measure? Yes, sir. Muy bien. And what's the other one going to equal? Just 30. There you go. And there are your angles. The vocab will guide you to what math to do with them. A lot of people today are going to see this problem and they're going to think, ooh, 5x equals x because, that's just kind of the simple thing we think of when we see two quantities. But the vocab will tell you. Now, if it had said, let's say this picture wasn't here. It's gone. Let's say this had said that the two angles form a vertical angle. Let's say it said two angles form vertical angles. What are vertical angles with one another? They are opposite, but mathematically, they're the same. So if they're the same, then what should I do with them? Well, if two things are equal, then you set them equal. So had it said vertical angles, you would set them equal to each other. So again, the vocab will set you free. Here you go. We still have over 50 minutes to get this done.